Hey guys, and welcome to the full course on Introduction to Sensing Techniques in Embedded Systems, your gateway to understanding the core concepts and practical applications of sensing technologies in the world of embedded systems. This is a certified course, so make sure to fill out the form in the description after completing the session to claim your certificate. Don't forget to proudly share your achievement on LinkedIn and showcase your new skills. At Skill-Lync, we are dedicated to providing advanced, industry-relevant engineering courses crafted by professionals with expertise in the field. Before we begin, make sure to subscribe to our channel for more insightful tutorials and updates on cutting-edge engineering tools, techniques, and courses. Hit the subscribe button below and stay tuned. Here's a brief overview of what we will cover in this training video. In the first module, we will introduce you to embedded systems. You will explore how these systems combine hardware and software to create powerful solutions with real-world examples like automotive control systems, consumer electronics, and medical devices. In the second module, we will discuss the need for sensing techniques in embedded systems. Learn how sensors bridge the physical and digital worlds, enabling critical applications such as temperature monitoring, collision detection, and step counting. In the third module, we will dive into the basic fundamentals of sensing techniques. This includes selecting the right sensors, interfacing them with processing units, acquiring and processing data, and converting raw data into actionable outputs for storage or display. In the fourth module, we will explore a detailed case study on fitness bands and smartwatches. You will learn how devices integrate temperature sensors, heart rate monitors, accelerometers, and more to deliver advanced features like blood oxygen monitoring, step counting, and fall detection. In the fifth module, we will focus on the essential skills you will gain from this course. Master communication protocols like UART, I2C, SPI, and CAN, and learn sensor interfacing and embedded system design techniques to tackle real-world challenges. Finally, in the last module, we will discuss career paths and job opportunities in embedded systems. From roles like IoT developers and embedded Linux engineers to robotics and automation engineers, you will gain insights into the required skills and explore industries actively hiring professionals with expertise in sensing techniques. So, thank you for joining us. We are thrilled to have you on this learning journey. Don't forget to subscribe to our channel for more updates and detailed tutorials. Complete this session, earn your certificate, and share your achievement with your network. Let's get started with Introduction to Sensing Techniques in Embedded Systems and unlock your potential in this exciting and ever-evolving field.
So today we are going to have a very interesting field in the embedded system, that is sensing techniques. What type of sensor we use, how we interface those sensors with our embedded systems, and what are their practical uses. So let's get started. So these are the topics that I'm going to cover in today's webinar. Introduction to embedded systems. Yes, we are going to discuss and have some brief idea of what embedded system is. And then obviously the need of sensing techniques, why we need to study sensing techniques in embedded systems, and how it is going to give you benefits. Then we'll be having basic fundamentals, how sensor is interfaced and how the data, we read it from the sensor and how we basically communicate to the sensor, and then what algorithm we put, how we process the raw data which we acquire from sensor, and after that what we do, whether we store it or we display it. So we will be having a basic fundamental like how to interface and how to design a sensor-based embedded systems. Then we'll be having a beautiful case study, which is nothing but a one of the most recent embedded product which is already there in the market. And then later we'll be discussing on what skills you will be learning with this course, and the job prospects, like which job designation you people can target. And then later we'll be having one query session. So yeah, let's start with the embedded system. So what do you mean by embedded system? You people might have read somewhere or listen, or you might have studied what embedded system is, but basically what do you mean by embedded system? So it is nothing but a combined system. What do you mean by embedded? Embedded is nothing but, combining something. So embedded system is basically combining some small systems on a single platform. So it is nothing but your attached or combined system. And since this term, the embedded system, is related to electronics, so that's why these small components or these small modules will be your electronic component. And yes, with its driver software, but keep in mind sometimes we don't need the software in it, so that's why it is optional. So what is embedded system? It's a combined system with electronic component and its driver software, which is optional. So I'm keeping it as basic as it should be. It is not like those hi-fi definitions which are really difficult to understand. So embedded system, if you people have asked, like what do you mean by embedded system? So it's nothing but a combined system. A system which has a lot of other subsystems is nothing but your embedded system. So I have dragged a lot of examples which you people can relate to. So the first real-time example will be in the field of automotive control system. Automotive in the sense all the vehicle systems like two-wheelers, four-wheelers, then you have goods carrier, trucks, and you have the other smart vehicles and goods carrier system. So speed control, yes, whatever speed control system we have in our car or in your bike, if you are using, or if you have your personal bike, you might have seen nowadays you have a digital speedometer. So that digital speedometer is nothing but it converts your angular speed of your vehicle, and it displays onto your system. So yes, we can call it as an embedded system because we have a sensor here. That sensor calculates your angular rotational motion, and then it actually reads the data. We have some piece of code that code actually converts your raw data, and it shows and it calculates your speed in meter per hour or kilometer per hour, and we actually display it on our screen. So yes, speed control system is nothing but an example of embedded systems. Then we have engine control systems. Engine control system, we are not talking in terms of the pure automotive. Engine control system, here we are talking in terms of the embedded system. So engine control, nothing but like temperature controlling and monitoring. Actually, it is nothing but a engine monitoring system instead of control system. So we can have some kind of embedded system which monitors some engine parameters. Let's say one of the major parameter for engine is monitoring temperature of engine. So what we can have is we can have a sensor on the engine, and we can read the value of sensor, and then again we can process it and calculate the actual temperature, and we can store it or we can display it. Same lighting control, you might have seen in a lot of vehicles we have front light, back light, side lights, then we have different patterns, the light patterns, and again this is also being controlled with the help of embedded systems. Then in automotive we have one of the most important feature, that is safety control systems. This has been launched very recently because this was not there in early 90s and 80s, but nowadays a lot of automotive manufacturers are giving safety control system, including your airbag system, like how that functions. Then we have for that they actually use some collision sensor, and they actually calculate you know whether the vibration or the collision of your vehicle has crossed to one particular threshold limit, and based on that they determine that whether your vehicle has encountered with any accident or not, and based on that they open airbags. You might have seen that nowadays cars are equipped with airbag systems. So yes, for this also we need an embedded system to read the collision value of the vehicle, and based on our collision value we trigger our airbag system. So yes, safety control system is also part of embedded system in automotive. Then again we have a display control system which actually displays, controls, and monitors all the other systems including speed, engine, light, and safety. So in automotive control system also we use embedded system a lot. And the next example would be very relatable to you. It is in the field of your consumer electronics. Here we have obviously the television and radio system, whatever TV, starting from the old TVs you might have seen, with the big CRT inside in it, till today what type of technology we are using in television, like OLED, and we have LCDs, and we have other technologies and displays. So for that also we need embedded system, because whatever signal we are getting, the audio signal and the video signal, that signal, they captures it and they convert the signal in your display format. So basically you need a kind of graphics embedded system where it converts your signal into your display. And then again, where the sensing technique comes in TV and radio system, definitely for TV, I have something called a remote control, which is used to control my entire TV remotely. So again, for remote, we have one IR sensor, and we on the set-top box or maybe on the TV itself, we'll be having one receiver. So based on my inputs from the remote, whether you want to change the channel or whether you want to increase or decrease your volume of the TV, or whether you want to do any brightness setting or any television setting or audio setting, we use remote. So yes, basically this is also a very important sensing embedded based system, TV and your radio system. Then again, cellular devices means your cell phone. This is again one of the widely used embedded product in the market. Cellular phones, it is an embedded product because it has a lot of features. You can have a call, you can record a lot of things, you can play a video, you can play audio, you can record audio, and then we have a lot of other sensors. Let's say for gyroscope, to turn any image or video from portrait mode to landscape mode. And we have what you call your proximity sensor, like whenever you're on a call and when you keep your phone near to your ear, then the backlight immediately turns off. So again, that has a sensor. So basically it has a lot of subsystems, including on a particular one combined system. That's why it is an example of embedded systems. Then again, the recent consumer electronic product, that is smart watches, whatever you see, fitness bands, fitness trackers, people tracker, then your other watches which has some special feature in it. So all these watches are nothing but a lot of features embed into it. So that's why we can take this example in the field of embedded system. So the next example field will be again medical devices. Then here in medical devices, we'll start from the old devices like X-ray machines. Then we have MRI scans for brain. Then we have CT scans. Then we have sonographies. Then to the recent ones with heart rate monitoring, then oxygen level monitoring. Then we have blood sugar monitoring. So all these machines, all these small devices nowadays companies are launching. These are nothing but your embedded products, because these devices have a lot of sensors, a lot of features in it, and all these features are combined on a single platform or a single device. So yes, we can include medical devices also in this field. And the last would be obviously some confidential fields like defense, aerospace, scientific R&Ds like ISRO, DRDO, NASA, SpaceX, and the other private organizations which works on R&Ds. So yes, to do a lot of R&Ds, we need embedded system, we need electronics, and we need sensing techniques. So this is the brief about embedded systems, and these are the fields where you use, and these are all familiar fields, and these are all familiar devices, and that's why I put here. And this is what about your embedded systems. So next we are going to have something which is really important and something which is related to this webinar, and that is, why do you need sensing techniques? So why do we need a sensing technique? Why do I learn if I'm a fresher, if I'm pursuing by engineering in the field of, let's say, electronics communication, electronics telecommunication, or maybe electronics and electrical, or whichever field which they have included embedded system as a subject. Why do you need to study sensing techniques? So let us look into it. Why do we need actually? And for that, let's say, and I will give you an example. So the example would be like, definitely, embedded system fulfills purpose of a given requirement. Why do we need to study something? Because that is going to give you some kind of outputs. Or if you have a requirement, then only you're going to study something. Now, why you're studying? Because you need to have a job. You need to have a proper career, and you need to have a lot of other plans in your life. So everything has a purpose. So why we design embedded system? To fulfill a given requirement. Let's say I have a requirement where I need to design one temperature monitoring system for a particular, let's say, a geyser or maybe a furnace. So that is my requirement. So for that, I need to design one embedded systems. So basically, with embedded systems, we actually solve critical problems which is given to us, and these problems are going to definitely make our job easy, and with proper efficiency and durability. And around 70 to 90% of all these requirements are actually related to connecting the outer world to your digital world, which means, let me give an example. I want to design one temperature based embedded systems. So what is my temperature? if if there is a requirement that I have to design one temperature system which should continuously monitor my let's say my geyser temperature, or my, if I have any furnace, so the furnace temperature. So what do you mean by temperature? This is nothing but a physical quantity. Temperature is physical quantity. Temperature rises based on the atmosphere temperature or the device temperature. So that is nothing but my physical quantity. So these physical quantity, somehow I have to design one system which should read that temperature or that physical quantity and converts it into my digital quantity. So that physical quantity we need to convert into digital quantity. So most of embedded products, whatever you see around you, these are nothing but converting your physical quantity into digital quantity, and then process it, and then store it and display it. So by this way, we can definitely say that a lot of embedded systems are nothing but the devices which are designed to convert your physical world into digital world. And here comes your sensing part. Your sensing technology plays very important part, because again, yes, whatever device you have, you need to know that, let's say I have a temperature sensor. How am I going to interface that temperature sensor? Now forget that. First, you need to think that what type of temperature sensor do I need to use, because there will be a lot of temperature sensors available in the market. What are the design aspects that we need to consider, so that will be suitable for your requirement? That should be the first question. Then based on that, we can go further and see like how we are going to interface the sensor, what type of sensor we are going to use, what parameter of the sensor we should consider, like the efficiency, like the temperature range, like the resolution of the sensor, the durability of the sensor, and then what feature the sensor has. Feature in the sense, some sensor have memory in it, and some sensor have some small controlling protocol in it. So it is not basically a sensor. You can actually store the data inside sensor also. So this is just an example that I'm giving you, like in terms of the feature. So how are you going to design it, and that, and there the sensing technology comes, and it really plays an important part. And why I've put it this, because you take any embedded systems, you will definitely find out that at least one feature is related on sensing techniques. So that is the reason why we need to learn sensing technology. So here I've given you one very relatable example, that is your COVID-19. And you already know that nowadays the entire world is suffering from COVID-19, and it is really difficult for everyone. And yes, we have a lot of people to appreciate for it, like doctors and the other medical research companies and organizations who are really doing great jobs, and hands off to them. And we really hope that this should we should get from this over very soon. So yes, during this pandemic, a lot of people are engaged, like how do we cure about this virus. And to cure it, first we need to understand all the parameters, like when it goes inside human body, what happens to your human body. Then only you will be able to understand, to have a solution for the problem. So it is like, to giving solution for a particular problem, you need to have a clear picture of your requirement. So for that, doctors and researchers have found out that the COVID positive patients, they faces breathing difficulties. So at some stages, their oxygen level goes down, and that oxygen level is unpredictable, which means you cannot predict. If you have 10%, 10 positive COVID patients, then it is very difficult to determine that the decrement of oxygen level is steady. It depends on a given person's immune system. So based on the immune system of a person, it varies. If the immune system of a person is very weak, so there is a chance that you can have, or you can see, droppage in the oxygen level very fast or very vigorous. And for this, if let's say we have a hospital and we have more than 500 patients in it, it is very, very, very difficult to monitor each and every person's oxygen level, and to have this report that yes, for particular patients the oxygen level is going down and they need medical support. So for that, definitely we need a lot of manpower. If we have 500 patients, it is very difficult to manage also. So why not to develop a device, why not to have a portable embedded device which keeps on actually monitoring your temperature. I have actually missed one point here. You can add temperature sensor, oxygen and heart rate, and all these features we can monitor with one embedded device. And actually we can have one networking in it, so that all these devices will be connected wirelessly to my local network of that particular hospital. So that, let's say I have 500 patients, so I have small device which you can put it inside your finger, or you can wear it as a wristband. It depends on how we want to design it, and we can assign that particular device to each and every patient. So, and we can have a monitoring system. So like, let's say after every 1 hour or after every 30 minutes, it will calculate temperature of the person, and it will calculate the oxygen level of the person, it will calculate the heart rate beats per minute of the patient, and it will keep on storing in our network. And we will be having one supervisor which will monitor, like which patient's oxygen level, temperature, and the heart rate is proper, and whose is going down and up. So we can create one critical alerts as well, like we can set one threshold in that. We can have something like, if the system will notify us that okay, out of 500 patient number 5, patient number 10, let's say patient number 100, their oxygen level is going below 80 or below 70. It's just like what threshold level is set. So it is very easy to cure them, and it is very easy for the medical institution to look into and to have a proper system. And for that we need very less manpower as well, because again, more manpower means maintaining social distancing, and the other maintenance would be very high. So instead of that, we can have a product and which have a lot of sensors, which have a lot of medical related sensors, and by this way we can definitely solve this problem. So yes, this is the reason why we need sensing technology. This is just an example which I have given you. This was the requirement. We have worked on it. We have analyzed, or someone else has given this analysis. Let's say this was our requirement, and based on that, we developed something which is related to sensing techniques. So yes, this is the reason why we need to understand sensing techniques. If let's say you join a company, or if you want to join a company, and if they give you this project, let's say by God's grace, if you get the same project, then let's say you have all these basics already with you. If you have already learned all the sensing techniques, how to interface sensor, how to acquire data, how to process data, what algorithm to put, and how to write a code in terms of hardware and in terms of software, how to design it, then it will be really benefit. It will be really beneficial for you to have a better career and to have very in-depth knowledge of your embedded system. So that is the reason why you need to have sensing techniques and why you need to study sensing techniques in embedded systems. This is all about our sensing basic fundamentals. Again, I'll be keeping very basic, and the reason why I'm keeping it very basic, because this course will be a platform independent course. Yes, definitely we'll be choosing one platform to have this course, but whatever you're going to learn, that will be from the grassroots level. From the root level, from the very basic level, we are going to understand all the sensor protocols, so that you can use all these techniques, all these things, whatever you have learned from this course, to any other given platform to you. Because what happens is, if you join a company, it is not possible for a company to work on similar kind of platforms. So let's say for a given project, you might have to use one particular platform. Then for other project, you might have to use some other platform. So what keeps remaining same is your protocol, your basic understanding. Your basic understanding is same, your protocol remains same. Your protocol is not going to change, only the platform the company is changing, not the protocol. So if you have proper protocol, you can definitely develop anything on any given platform. That's why with this webinar, you will be having a proper basic grassroots level of understanding of your sensing of embedded system. So basic fundamentals, it will be very basic. Let's say I have a sensor. Let's take any sensor. Once I have a sensor, I need to first decide what type of sensor I need to use. Let's take an example of temperature sensor. So what type of temperature sensor I need to use? It depends on a lot of things, like what are the voltage levels that I need to select. There are different industrial voltage levels like 1.8, 1.7 volt, 3.3 volt, 5 volt. It depends on your processor system also, like what voltage level your system supports. And then the interface system, data acquisition interface system, what interface you're going to use, how are we going to interface the sensor to our processing unit. So that comes in your data acquisition, how we are going to acquire, or how we are going to read, or how we are going to communicate with the sensor. Then again, once we have raw data, how are we going to process it, how are we going to convert the raw data into the relevant data. Let's say I have a temperature sensor. So the sensor will not give you the raw data in terms of temperature. The sensor is going to give you in some other format. So that format you need to convert it into temperature format. So for that you need some piece of code. So how you're going to write the piece of code and how you're going to process it. And then after processing, obviously we need to store it, display it, or we can use the data for other processing also. So this is the basic fundamental of my sensor based embedded systems. Not going any further deeper version, because I think this is what we need to understand first, like the basic fundamentals, and then later we can go and look into like what we need and how we design it. So just example, temperature sensor, data acquisition. Let's say I'm using any serial interface. Let's say I use UART as my serial interface, and then for that, for my processing, I have to choose one processing unit. So I may go for any microcontroller, or I may go for any microprocessor also. And then again, displaying and storage. So we can have a digital display like LCD we can have, or any other displays we can have, or we can send the data remotely to my remote cloud or remote network. So this is my basic fundamental, and this is what you need to have to understand or to design any sensing based embedded system. 4 steps, very easy: sensors, data acquisition, processing, display, and storage. That's it. That is all you need to know, and that is all I have explained to you. So the next would be my case study. Yes. So as I mentioned earlier, we will be going to discuss a very beautiful and very relevant, very fresh case study, and which is nothing but my fitness bands. You might have seen a lot of fitness bands, lot of fitness watches nowadays. Nowadays, a lot of companies are going into this market of launching fitness bands, fitness tracking bands, smartwatches, and all those stuff. And I think one of the band is familiar. This, you can see, this is Apple Watch, and this is one of the most advanced fitness band or the smartwatch nowadays available. And with that, we have a lot of others and dedicated fitness bands available in the market. And why I have chosen this topic is because this was one of my recent project, and we have completed this project. So yes, what and how the fitness band works, and what are the features are there, and how all the feature works. So I'm going to just explain you briefly about it. I will not take a lot of time on explaining each and every features. So let's start with temperature first, because that is the basic feature. So I have a band, I have a fit band, I have a smart watch which has temperature feature. So how it works, basically in the watch you'll be having some metal contact, or you will be having some sort of sensor which will, firstly the band you have to wear it on your wrist, or maybe wherever the company recommends you to wear. So based on your skin, it will calculate temperature of your body. The temperature sensor is going to calculate temperature of the body, and generally industry uses temperature sensor which has some kind of memory unit in it. What do you mean by memory unit? So what happens is, let's say I have a temperature sensor. So it is very difficult. Let's say I have 30-40 sensors I have interfaced to my controller, and if let's say I want to monitor and I want to read data from all those 30-40 sensors simultaneously. So instead of that, instead of reading simultaneously, we can choose a sensor which has memory device in it. So what will happen is, we will send a command to sensor. The command will be like, read the data, and instead of sending it back, store it in your memory itself, so that whenever the processor needs it, we can able to retrieve the data. So it is very important feature nowadays. Most of the sensors are coming with this feature where they have memory unit in it. Memory unit in the sense, they'll be having a lot of registers. If you guys are from electronics, you can understand what you mean by register. Register is nothing but a digital storage device, or a component, or a design which is used to store digital data. So what happens is, like from the controller or from the chip, we will be sending one request to the sensor that start the conversion, for starting the conversion, and read the data, and keep on storing the data into the sensor itself, because we will be having other processes to do. Because this is not related to only acquiring data and displaying, because we have a lot of other processes, a lot of other sensors. We need to manage it efficiently. So for that, instead of reading continuously, we will read whenever we want to read, and we will start the conversion. So for that, we can have a feature like, we can choose one sensor which has this feature, and then simply reading the temperature whenever we want it. So we'll be having a good amount of data, and the sensor will have also some features where the sensor gives you a alert, yes, that the data is ready. So that is nothing but your data ready signal. So we'll be sending start signal to the sensor, and the sensor will start reading. Sensor will store some amount of value, and when sensor says that yes, I have stored it and my data is ready, so the sensor will send you back the signal, not the data. It will send you a signal. It will signal your controller or your processor that yes, data is ready, and you can read it from the sensor. So this is how we can read a temperature sensor, and this is how we read it. Instead of reading it continuously, we set some parameters. Based on that, the temperature calculates by itself and it keeps the data ready. And whenever the user requests to read the temperature, let's say on my smart band I have a button or I have a touch button. If I touch on temperature, so once I touch it, it will send a request to my sensor that yes, I'm ready to read the data. So after that, the processor will check whether the data is actually ready or not. So we are not going to read it every time. Once you touch or once you request from the band that you need to read temperature sensor has to acknowledge basically that yes, my data is ready and you can read it. So once I get the signal, I'll be reading it. I'll be writing one piece of code to convert that raw data into my temperature data, and I'll be displaying it that okay, this is your body temperature now. With that, we can have other features also. As I said, you can keep a timer. The timer will be like, after every 1 hour I can, or after 30 minutes I can set a timer, and the timer will calculates your temperature after every 30 minutes, and it will keep on storing in your band. Our band especially we design with the memory, one small amount of memory which stores all your reports in it. So in the form of reports we can store the temperature. So the same principle we use for other types of features and sensors also. So let us discuss something which is new to the market, that is your heart rate and blood oxygen level. So how do they calculate heart rate and blood oxygen level? I'll just give you one brief idea because I have worked on blood oxygen level and heart rate for more than 7 months and the algorithm in it. So basically how it works is, let's talk about heart rate first. I will not go much deep into the biology of how your heart functions, but basically how your heart function is. Our heart is responsible to pump and depump two types of blood in your body. It pumps the blood which has oxygen in it, that is called oxygenated blood, and it retrieves or depumps the deoxygenated blood, which is the blood which is not having oxygen. So that is the primary function of your heart. It pumps and it depumps, it compresses and it rarefies your oxygen and deoxygenated blood. So it takes oxygen from your lungs. So your lungs passes oxygen to your heart, and the heart mixes your oxygen with your blood. Again, I'm not going in deep like how it mixes and all. Just I'm giving you an overview of how a heart functions. So this is how your heart works, and this is the main function of your heart. So what happens is, how to calculate heart rate. So what we have done is, we have chosen one special type of transmitter that actually transmit one special type of light, and that light and that particular sensor, you need to keep it on your wrist, or maybe that sensor you need to touch it by your finger, or wherever you have a proper blood circulation in your body. Keep in mind, it should not be placed on your bones. It should be placed somewhere on your body where you have good blood circulation, or where you have veins and arteries properly. Okay, so how it works is, we'll be keeping the sensor on, let's say I have a band based sensor, so I'll be keeping it on my wrist, and we'll starting one special type of LED sensor. That LED sensor will actually penetrate my skin, and it will go inside, and let's say I have a vein which carries blood. So, and then just below that I have bones. So it will go and it will reflect from the blood. And then I'll be having a special type of receiver, that light receiver. So I have a special type of LED, I have a special type of light receiver. So basically I have special type of transmitter, I have special type of receiver. So I'll be transmitting data, I'll be transmitting some kind of light data, and your blood is basically made up of RBCs and WBCs, that is red blood corpuscles and white blood corpuscles. Your white blood corpuscle WBCs are responsible for your immune systems and a lot of other things. And your red blood corpuscles are actually related to carrying oxygen and carrying other vitamins to your body. So what basically happens is whenever you transmit any light signal, your RBC, red blood corpuscles, they're going to absorb some amount of light which you have transmitted. So what happens is whatever data we receive in our receiver, that is in the form of that gives us the randomness, and that randomness is based on your heartbeat. When your heart pumps, at that time we'll be reading or we'll be getting some different value in our receiver, and when your heart retrieves the blood, at that time you'll be getting different type or different value in our receiver. So we'll be having different rate of values which we are getting in our receiver. So yes, these are the raw data that we are going to get. And again, heart rate is calculated as beats per minute. So we have to run this algorithm for 1 minute. So for 1 minute, we have to keep on monitoring the data. With this data, we'll be getting some raw value, and these raw values we actually put one strong digital signal processing algorithm we have designed, so that you might have seen in ECG graphs that how our heart beats. We have a big wave and then we have a small wave. So we actually calculate the thrust of that big wave, and we calculate that how many thrusts are there in a single minute. So based on that, we calculate heart rate of a system. So again, for this band, the system will be same. Whenever you request heart rate, from your band, it will send one request directly to the sensor. Sensor will start calculating the heart rate, calculating the raw data, and it will not give you the data back. It will keep on calculating and will keep on storing the data into its memory unit. Once the data is ready, the sensor itself will notify you that yes, data is ready and you can read the entire data, and that we'll be reading that the entire data, and then we'll be putting the data into one algorithm, and then we'll be calculating the heart rate of a given person. And this is the same method which I have explained you in the basic fundamental, like having a sensor, retrieving the data, putting some algorithm, storing and displaying. That is what you need. And again, one more very new feature is your blood oxygen level. Blood oxygen level, again, it works on the same principle as the heart rate works. Your red blood carries oxygen, and when you pumps and depumps, when your heart pumps and depumps your oxygen, your blood, then based on the data we get on the sensor, that actually saturates, like when it pumps, we'll be having more oxygen in your blood, and when it depumps or when it retrieves, we'll be having lesser oxygen. So that ratio we calculate, and that ratio is called the blood saturation ratio, that is SpO2. There's a special term for that, SpO2 level monitoring. For blood oxygen, we actually use heart rate also. So to read blood oxygen level, first we start heart rate, and then based on the beats, we calculate the raw data for blood oxygen level. So this is one of the latest features that a lot of companies are giving for Fitbands, because nowadays it is really important, because after the COVID-19 pandemic, it is really important to be healthy and to track your body, like how your body is functioning and what is your heart rate and how much oxygen you have. So it is really important nowadays. A lot of people, they are really becoming health conscious, and which is very very good thing, and that is the reason why a lot of companies are going into this market. This is how this works. So then again, we have other fitness features like step counters and fall detection. Step counters and fall detection uses a single sensor, which is your accelerometer, which calculates the acceleration of your body based on the gravity acceleration, that is acceleration due to gravity. So it calculates your acceleration into 3 dimensions, 3 axes, X, Y, Z. And with the help of this, we can calculate step counter and fall detection. You might have experienced this sensor or this feature, not this feature, but the use of this sensor in your cell phone. So there is a feature in our cell phone called, whenever you turn your phone in landscape mode, so your video or photo or whatever you're watching, it automatically turns. So this is the use of accelerometer, or there is one more sensor called gyroscope. So with the help of these sensors, they use to rotate the screen of your cell phone. So okay, that is different part, but now we're focusing on step counter and fall detection. So how step counter works? So step counter is basically how many steps you have walked. It's like a walking counter, how many steps, and like it will calculate the steps you have walked. And how it works basically is it works on your vertical axis acceleration. So like whenever a human moves, whenever a human walks, there's a little variation in the vertical acceleration, the vertical axis acceleration. And the sensor is so accurate to calculate that vertical axis moment in the form of step. Because there might be one doubt that, a lot of people have small steps, a lot of people have bigger steps. How we calculate it? So let me clear you that this step counter is not based on your the distance, how you what is the distance between your steps. So it is basically on some other technology, because if it is based on your distance, then this is not possible, to develop such kind of feature, because every human will have different steps, every human will have different speed also as well, and that's why this technology will not work. So the basic technology is it determines the variation in your vertical axis of your acceleration, and based on that it counts the step. Again, the technology is same. Whenever you want to start step counter, just give an alert to the sensor. The sensor will start step counting. It will keep on storing into one memory unit or into one dedicated register inside the accelerometer, and whenever the data is ready, it will notify to your controller. And it depends on the controller whether the controller wants to read it at that time or not. And again, we can have continuous step counting feature where you can continuously calculate and keep on storing the step counters. Then again, for fall detection is important. If you are working in a factory, or your labor, or if you're working in some goods carrier vehicle, goods carrier transportation job, there if this feature is required where you're falling it suddenly, or if some accident happens, basically if some accident happens to you or while walking, or if you slips away or something, anything happens, then again, based on the accelerometer, whenever you fall, you'll be having, one sudden drastic change of the acceleration of the sensor, and based on that, the device calculates that yes, the fall detection has occurred, and it will actually store and give you one notification, yes, the fall detection has occurred. And this feature can be enabled, disabled. And yes, this also works on the same. We'll be keeping this feature on in the accelerometer by sending one command to the sensor, and the sensor will keep on reading it. And once the fall detects, the sensor will keep on storing the data. Yes, fall has detected, and whenever we want it, we'll be reading. Otherwise, we will just GPS tracking and social distancing features also. This is the recent feature that, yes, I can say that social distancing and GPS tracking. The why, I'll just wrap up with these two things: GPS tracking and social distancing. Let's say we have a quarantine place. You might have aware now because of this COVID-19. Is like what do you mean by quarantine places, where where we keep people isolated from the other crowd for a given period, let's say for 15 days or 20 days. So sometimes people violates the rules and regulation. They cannot stay inside a room, or they cannot be quarantined for more than 10 or 20 days, or whatever the rule is. So instead of monitoring them continuously, just give them a particular device which will have a GPS tracking, and based on that we can actually check whether the person has violated quarantine rules or not. So we'll be keeping one radius. So let's say I have quarantine place, and from that place I'll be keeping one quarantine radius of, let's say, 500 meter or 1 kilometer. So if a particular person from that quarantine center crosses that particular range, so with the help of GPS tracking, we can actually predict that yes, so and so person has violated our rules, and we can take necessary action on him. So it's a cool feature that nowadays people are providing. And if they're not providing, so this feature can be added into the smart watches, and into the dedicated watches. And again, social distancing. This is the specific dedicated feature for bands. If we have two similar bands, or if we have given the similar bands to quarantine people or to people who work in public sectors, so we can set a particular radius. So if two person comes near each other with a minimum distance, or if they crosses the minimum distance, the band will generate an alert, and the band will notify that okay, you're not maintaining social distancing and you need to maintain it properly, or something like that. So all these features for social distancing, actually we can use any wireless technology. So most of the bands uses BLE connectivity, that is Bluetooth low energy, so that all the features can be controlled and monitored from your smart mobile applications or your servers. Because since Bluetooth supports low energy feature, it uses very low power, and it is very accurate, authenticate. We can have a lot of encryptions in that, and the same technology can be used for social distancing also. Bluetooth, basically what Bluetooth is, it's nothing but a radio communication. So it transmits the radio power, and let's say you have two bands which are transmitting radio power, so you can actually calculate like what is the power level of your other device. So based on the power level or the transmit power level of your other devices, you can have this social distancing feature. We have actually developed a social distancing band, and we are going to launch it very soon. So I cannot talk on this social distancing feature on depth. So, but I can give you one small brief idea about how it works. And yes, a lot of alerts and reports we can generate on our band. Let's say we can trigger all the events at a time with particular interval. Let's say after every 5 minutes my heart rate should display, after every 10 minutes my blood level should display, after every 15 or 20 minutes my temperature should display. Then sleep quality, yes, I forgot to add sleep quality. Sleep quality is nothing but analyzing all the parameters, analyzing your heart rate, analyzing your movement while you're sleeping, analyzing your temperature while you're sleeping, analyzing your oxygen level while you're sleeping. So based on all this combination, we determine that the person had a good sleep or not. So for this, we don't have a special sensor, or maybe in future R&D centers or companies can develop a special sensor. But right now, we don't have a particular dedicated sensor for quality, sleep quality. So all these features can be triggered periodically, or they can be triggered manually. So this is how a band works. And why I have chosen this project, again I'm telling you, because this is very much relevant to our webinar. This is very much relevant to our course, because our course is sensing techniques, and this product is full of sensors. So if you join a company, let's say, and they're working on such kind of products, and you have already knowledge on these technologies, I'm not talking about the sensor part, I'm talking about the technique parts. Again, sensor can be anything. You need to know the techniques, how to interface it. So that is the reason this case study I have taken, and which is very important. And I think this is very much clear, like why sensing technique is very important. So this is all about the case study. Then we'll be discussing about the job prospect parts and the skill parts. Now, what are you going to learn from this course, and how is this relevant to the current job scenario? So generally for embedded system jobs, the companies or recruiters, they ask for, let's say, if you are a fresher or if you are experienced, you should have knowledge on a lot of things, and how this workshop will be beneficial for you, and how this will help you to have a better career. So we have a communication protocol. Yes, we are going to cover a lot of communication protocol, and this workshop will cover most of your communication protocol. And all these protocols are used in all the industries, and they have not changed any protocols, or they have not designed any new protocols. So the protocol remains same. So yes, if you have knowledge on this protocol, it is really helpful. I2C, UART, SPI, CAN, and then we have other derived protocol from this basic protocol. So we'll be covering these protocols as well, and this will be really helpful. Then this workshop will be helpful for your IoT development related jobs also. Like in as a fresher, a lot of company hires IoT developers. IoT developers, IoT software developers, IoT hardware developers. IoT product, what do you mean by IoT product? Like, earlier I've given you an example, monitoring temperature sensor, or I have given you the COVID-19 example, where you need to design a a device which calculates or your health related parameter and store it. So basically with this workshop you will have all the techniques which are required for your IoT development. And then again, robotics and automation, this is slightly different field from embedded system, but yes, it is related to electronics, but it's a slight different field in embedded systems, like designing robots, designing process automation in the sense of pick and place machine or sorting machine, or some kind of arrangement machine. Then designing SPM is special purpose machine. Designing welding robots, then designing sorting robots, and all those robotics field. Definitely you need to have knowledge on sensors, and that is why this course will also help you to have a clear picture on robotics and automation sensing techniques. Then again, one more very relevant job profile in the market today is embedded Linux device drivers. So what do you mean by device driver is nothing but, what do you mean by device driver? Device is nothing but my electronic component or electronic sensor or a different subsystem or a different embedded system, I can say. So device driver is nothing but to develop a software or piece of code which is responsible to communicate to that particular device. So device driver is nothing but making a driver, which is making a software which is responsible to communicate to that device in Linux platform.